Hello everyone. In this video, we will be discussing about design of machine elements 2 module 5. So, introduction of module 5 is basically about lubrications, bearings and anti-friction bearings. So, these two major topics we will be discussing in this module. In this particular video, we will be discussing the introduction part of the very first chapter, that is lubrication and its property. So, what do you mean by lubrication? As we all aware that the prevention of metal to metal contact by means of an intervening layer of fluid or fluid like material, we call it as a lubrication. Why lubrication has to be provided? So, when two metal parts which will be making a physical contact during the operation, that leads to the friction. And if you are not providing the proper lubrication in between the two metal surfaces, means that leads to the like a friction and finally leads to the wear and tear. To avoid that and to reduce that only, the lubrication should be supplied. And when I'm speaking about different types of lubrications, first let me start discuss about the types of sliding lubrication. So in case of a sliding lubrication, I have four types, that is sliding with the fluid film lubrication, sliding with the boundary lubrication, sliding with extreme boundary lubrication and sliding with the clean surfaces. So now I will be discussing all these four types in detail. So first let me start with the hydrodynamic lubrication, which is also called as thick film lubrication and fluid film lubrication. So metal to metal contact is prevented, and this is shown in the figure. You can able to see the red color and green color is nothing but two different metals, and these two metals has been yellow proper lubricant is provided in between these two metals, and the friction in the bearing is due to the oil film friction only. In case the friction is produced, means that is due to the oil film friction. And the viscosity of the lubricant plays a vital role in the power loss, temperature rise and even the flow through of lubricant throughout the bearings. So the principal operation is the hydrodynamic theory. So this lubrication can exist under a moderately loaded bearings running at sufficiently high speeds. And moving to the second one, that is the boundary lubrication, which is also called as the thin film lubrication. And here you can able to see like where the lubrication is provided on the boundary. So during starting and stopping, when the velocity is too low, the oil film is not capable of supporting the load. So there will be a metal to metal contact of some part, which is shown in the sketch, and the boundary lubrication exists also in a bearing if the load becomes too high or if the viscosity of the lubrication is too low. The mechanical and chemical properties of the bearing surfaces and the lubricants also plays a very important role. So next one is oiliness, where the oiliness of a lubricant becomes an important property in boundary lubrications. Antioxidants and anti-corrosives are added to the lubricants to improve their performances, and additional additives are also added to improve the viscosity index of the lubricants. And when we speak about oiliness agents, so why it is used? So it will basically increase the oil film's resistance to rupture, usually made from oils of animals or vegetables. The molecules of these oiliness agents have a strong affinity for petroleum oil and for metal surfaces that are not easily dislodged. So oiliness and lubricity, that is another term of oiliness, we can call it as a lubricity, which is not related to viscosity and manifests itself under boundary lubrication, and it reduces friction by preventing the oil film breakdown. And moving to the next one, anti-wear agents, where mild EP additives which actually protects against wear under moderate load for boundary lubrications, and anti-wear agents react chemically with the metal to form a protective coating that reduces friction, which is also called as anti-scuff additives. And last one is extreme boundary lubrication. So under certain conditions of temperature and load, the boundary film breaks, leading to the direct metal to metal contact, which was already shown in the sketch. The seizure of the metallic surfaces and destruction of one or both surfaces begins. Strong intermolecular forces at the point of contact results in tearing of metallic particles. So flowing of softer surfaces by surface irregularities of the harder surfaces, and finally the bearing material properties become significant. So proper bearing materials should be selected. And you can able to see the extreme boundary condition, where the first one we could able to witness like the direct physical contact between the two metallic surface, and in this boundary only the proper lubricant should be provided, where a micro weld should be made, and we need to make sure that whether it is present in the plastic and the elastic zone, and in case if it is going to the elastic zone, then it will be difficult. We need to make sure that only within the plastic zone this micro welding should be done. So after the micro welding is done, then I will be transferring the metal like wherever the micro welding is, wherever I will be transferring the lubricant into that particular portion. So this is nothing but the extreme boundary lubrication. And next one is nothing but extreme pressure agents, where scoring and pitting of metal surfaces might occur as a result of this case. Seizure is the primarily concern, but additives are derivatives of sulfur, phosphorus or chlorine, and even these additives prevent the welding of mating surfaces under extreme loads and temperatures. Next one, stick-lip lubrication. This is all the like additional lubrication characteristics. So we'll discuss one by one. So the first, the next one is I think, but stick-slip lubrication. This is a special case of boundary lubrication when a slow or reciprocating action exists, and this is very rare applications, and when very few applications only we could able to see these kind of things. And this action is destructive to full fluid film. That's we said no, like the micro welding kind of thing. We need to destruct the component and later the lubricant should be supplied. And here the additives are added to prevent this phenomenon causing a more drag force when the part is in motion relative to the static friction, and even this prevents jumping ahead of the phenomenon. And next one is solid film lubrication, and which is very common in most of the places. Even we call it as a grease for bicycle, what is that, chains, and even some of the applications where physically if you can able to provide the lubrication, we can go with the solid film lubrication, like we will see. So when bearings must be operated at extreme temperatures, a solid film lubricant such as a graphite or molybdenum disulfide must be used, because the ordinary mineral oils are not satisfactory at elevated temperatures. And so much research is currently being carried out in an effort to find the composite bearing materials with low wear rates as well as small frictional coefficients. And moving to the next one, hydrostatic lubrication, where hydrostatic lubrication is obtained by introducing the lubricant, which is sometimes air or water, into the load bearing area at a pressure high enough to separate the surfaces with a relatively thick film of lubricant. So unlike hydrodynamic lubrication, this kind of lubrication does not require motion of one surface related to another. Useful in designing bearings where the velocities are small, or even sometimes it is very it is almost closer to zero, and where the frictional resistance is to be an absolute minimum. Next is elasto hydrodynamic lubrication, where elasto hydrodynamic lubrication is the phenomenon that occurs when a lubricant is introduced between surfaces that are in rolling contact, such as mating gears or rolling bearings. So almost for all the bearings, the recommended lubrication is nothing but elasto hydrodynamic process. And the mathematical explanation requires the Hertzian theory of contact stress and fluid mechanics. So first we will have a look on Newton's law of viscous flow, because it is very important when we are trying to understand about the lubrication and its the viscosity. So in the sketch I am talking about this particular sketch. So first let me explain of the content, then we will move to the sketch. So in the sketch, so I have considered a plate of A be moving with a velocity u on a film lubricant of thickness h. So imagine the film to be composed of a series of horizontal layers and the force F causing these layers to deform or slide on one another just like a deck of cards. Just you can able to see. And the layers in contact with the moving plates are assumed to have a velocity u. So those in contact with the stationary surface are assumed to have a zero velocity, and the intermediate layers have velocity that depend upon their distances y from the stationary surfaces. So Newton's viscous effect states that the shear stress in the fluid is proportional to the rate of change of velocity with respect to y. So thus T is equal to F by A, which is equal to Z into du by dy. So where Z is nothing but constant of proportionality and defines absolute viscosity, also called dynamic viscosity, and the derivative du by dy is the rate of change of velocity with distance and may be called the rate of shear or the velocity gradient. The viscosity Z is thus a measure of the internal frictional resistance of the fluid. And this is a sketch. We shall continue the remaining things in the upcoming video. Thank you.